So in this session we'll see the design patterns, and in design pattern, not all the design patterns, we will see singleton design pattern and immutable design pattern, right? Singleton design pattern, first one, and we'll discuss here what is singleton design pattern and when singleton design pattern is required, and how many ways you can violate the singleton pattern, right? New package, and package name is org dot design pattern dot p1 package, okay. And in this, say I have a class, hello class. Right, so this is hello class, and singleton pattern means for one class only one object has to be created. Even if you try to create the multiple objects of the same class, JVM should not create the another object, and it has to return the same object if it is available. If it already one object of class hello is already available with JVM, then JVM has to return the same object address. If not available, it has to create one and it has to return the address. But it should not create more than one object for a particular class. Say hello class, and I want to say that hello class should be a singleton. Means for hello class, JVM should create only one object, one instance has to be created. Even if you try to create multiple objects, JVM should not create. JVM has to give only the same object address, right? And say in the same package only, I'll take another test. So this is test 1, right? I need a main method here, and inside the test class I'll create an object of hello. So this is hello h is equal to new hello, right? One hello object is created, and again if I say, or I'll say this is h1 and this is another one h2, and this should be new hello again, right? Then two object is created. In JVM heap memory, it will create two object of hello. And how will you prove it? You can check the compare the reference variable h1 equality operator, h2 you know already the equality operator. If you can to reference type argument, then it compares the address of the reference variable, and if both the reference variable is pointing to the same object, then only equality operator gives true, otherwise gives false, right? So now here these two reference variable is pointing to two different objects, so this has to give false, because here you have created one object, here you have created another object, two different object is created, right? Run it. And it is false, means the object is different, it is not the same object. Now it is not singleton. Singleton means only one object has to be created, and next time if you say new hello also, it should not create a new object, it should give the existing object address to h2, means it should be like this. If I say hello h3 is equal to say h1, now what will happen? h1 and h3 both is pointing to the same object, right? How will you prove it? Say h1 equality again h3. If it gives true, then both the reference variable is pointing to the same object, right? And it is giving true, means it is pointing to the same object. Now what you want is, for hello class only one object has to be created in one JVM instance, and next time when you try to create another object, you should not create another one, it should be like this. Existing object address has to assign to another reference variable, and when you compare this, it has to give true, right? So if you want to do like this, then first thing what you have to do is, the constructor of this class hello, constructor should be private. Constructor should be private. Why constructor should be private? If we declare the hello class constructor as private, then we cannot access this constructor outside the class. Here we cannot access it. Then we cannot create any one of these objects, right? So first thing you have to do is declare the constructor as a private constructor. Currently here you have already one default constructor, right? And default constructor accessibility is by default class level accessibility. Class is public, hello class is public here. So the access modifier of the default constructor of hello also will be public. If you want to make it private, explicitly private hello, and this you can say here it is hello default constructor, right? You can say here it is hello default constructor, right? When I have declared this constructor as private, then here this is not okay, this too is not okay. Constructor cannot be called outside, so this I am commenting, okay, not possible. If it is not possible, then this statement also does not make any sense, so this is also commented. Now singleton means one object should be created. But if the constructor is private, you cannot create any one object also. Single object also is not possible to create here outside, because the constructor is not visible from outside, right? You cannot use it here. Singleton means one object should be created. So what you have to do is, since constructor is private, outside it is not possible to create the object, but inside you can do, right? Here you can do. So here what I'll do is, I'll create an object of type hello, new hello. One object is created, and this object address I'll store say hello h1 is equal to, or just hello h, right? From inside hello class you can create one object of hello. Inside the class you can access the constructor of private constructor of hello class, right? So by using this you are creating an object of hello. But here if I declare this as instance variable, then from outside here if I need an object of hello, constructor I cannot use because constructor is private, so I cannot call the constructor to create an object. And this age is a instance variable here. Age is a instance variable here. So if you want to access this age from outside, instance variable if you want to access from outside, then you need to access with the object reference. And from outside you cannot create object because the constructor is private. So what I'll do is, I'll make it static, right? I'll make it static. Now if it is static and if I need an object from outside, here I need an object of outside of hello class, right? And I cannot use the constructor because constructor is private. But inside the hello class itself, you have an object, and you can say, and it is static. So you can say here dot h, right? You can access it like this. Now you got an object of type hello, or I'll say it is h1. Constructor is directly not possible to call because the constructor is private. So what we did, inside the hello class only we have created an object of hello itself, and I declare that as static so that you can access it from outside directly with the class name, right? Now here I am accessing once. Again if I write hello h2 is equal to hello.h, it is the same object reference, right? So if I check here h1 equality h2, then it should be true. Check it. It should be true, right? It is true. But constructor how many times called? Only once. Object is created only once. And when the object is created because the hello class has to be loaded. When hello class has to be loaded? First time you are running class test. Inside the test, main method is available. Main method will start execution. Inside the main, local variable h1 is a reference variable, and when you will say hello.h, hello.h, when you will call, hello class has to be loaded. At the time of loading hello class, static variable h memory has to be allocated, and this has to be initialized also. This has to be done at the time of loading the class hello, right? Hello class when it will load, allocate the memory for static variable h, and initialize that with an object of type hello itself by calling the constructor, right? So at the time of loading the hello class, one object of hello class will be created by using the default constructor that will be stored into hello class inside the hello class method area only, okay? The reference is only in method area, and these you are accessing from outside with the class name directly, and you are saying hello.h, and again h1 is equal to h2, you are comparing and it giving true, because both is same age only you are referring, right? Both is same age only you are referring. So this is a singleton. Now for hello class outside, no chance to create any object, because constructor is private and one variable is allocated like this, and whenever you need an object from outside of hello, you just have to say like this. So this is done. This is singleton. It is perfectly fine. But actually the singleton pattern, when you will design, you should not say this as static, and it should not be directly accessible from outside with the class name. Why it is so? Because say you are declaring class hello, and somebody is going to use this hello class object. Some other person who is not designing this hello class, that guy is going to access the hello object from outside like this. Now if you want to access it like this hello.h, then that person, he need to know the reference variable name h. It can be h, it can be h1, it can be hello, it can be anything, right? So if you are not designing this hello class, then how will you come to know that what is the reference variable available in hello class which is holding an object of type hello? You don't know that, right? So you should not do it in this way. This is not okay. But actually the singleton pattern is done. Okay, finished. Singleton pattern is finished. But because of compatibility, what you have to do is you don't allow these to access directly. Declare that also as private. Okay, if this is also private, then this is not okay, not visible, you cannot do it, right? So this is also not okay now. So what you have to do is you have to declare here, you design a method, say getInstance is the method, and this getInstance method has to return this object address, and you can say here return h, right? getInstance has to return h. So the return type of this has to be hello, right? Return type of the function is hello. Now the function is again static. If you want to access it from outside, then you need to create an object first. Object you cannot create because the constructor is private. So what you have to do is you declare this as also as a static. Okay, static. Now very easy way, if you want to get an object of hello from outside, what will you do? Say hello dot, you have a method hello dot get instance. Very simple, everyone will try this, get instance. Okay, hello dot get instance. You don't need to know the h reference variable name, what it is, whether it is h1, h2 or hello or whatever. You don't need to worry about that. You just say get instance, right? Then it will return an object of type hello, and this is say h1 now, and again you say hello h2, again hello dot get instance, and you check h1 equality operator h2, right? Now check it, this is also again true, and the output is same, right? But the execution flow, you check execution flow. When you will say first time main method will start execution, test1 will run, main method will start execution. In that main method stack memory h1 is a reference variable, local reference variable, then it has to say hello.getInstance. But before hello.getInstance, hello class has to be loaded. Hello class has to be loaded. At the time of loading hello class, first it will verify all the static variables and initialize that with the value, right? A static variable is there, hello type itself. Memory will be allocated for that. One object will be created by using the default constructor of this class, and that will be stored into this. Class loading is over. So at the time of loading of hello class only, it has to create an object of hello class and it has to store here, right? This when it will do, you will just say when hello, done. Once the loading of hello class is completed, it has to say getInstance. When getInstance method you will call, and here it is getInstance function is called. It has to return the static variable h, which is already initialized with an object. Now even if you say 100 times getInstance, 100 times you getInstance, this will create the instance of hello. Sorry, creating is not required. Creating is done only once. Hello class is loaded only once, and static variable memory will be allocated only once for the first time when the class is loaded. So after that 100 times you say getInstance, it will not create the object 100 times, just function will be called. This will be done only once when the class is loaded, right? So in this point, class has to be loaded, object has to be created, it has to store into the reference variable age, and the object address has to be returned. That age has to be returned. Done. But next time when you will say first it is in stack memory age to memory has to be allocated. Done. Then when you will say hello.getInstance, at that time hello class is already loaded. It will not load it again. It is already loaded, and at the time of loading this task is already done. Now next time what it will do, it will just call getInstance, just call getInstance, and it will just say call getInstance, this age which is already ready, and this only will be returned again, right? So same object reference is returning every time, right? So first approach, what we see here, what I have seen, constructor we have used here, it is creating two objects, right? Because at that time constructor was not private, and in this we are assigning, so it was true, but in this case it was false. Now here what we did, we cannot say constructor because constructor is private. So inside the hello class we have created an object, and the object only we called in a static way with the class name, with the reference variable name, right? But reference variable name everybody does not know. So to overcome with this problem, what we did, this is already done, hello class object is already ready. Now what we did, this is not directly accessible with the class name, and you have to access through a method that is getInstance, right? With this you have to do, right? So getInstance function is called, and you got the object, and it is again singleton, and because it is singleton, so it is true, right? Now in this also, when you are saying this, right, at the time of loading the class itself, age memory has to be allocated and object has to be created and stored into age, right? Stored into age. This is fine, it is okay. At the time of doing that only, it is doing fine. Now assume I don't want to initialize in the same statement. Instead of that, I'll put this in a comment, and I'll write here private static hello age is equal to null first time age is null, okay, age is null, and I'll take a static block here. Inside the static block age is equal to new hello. Inside the static block only I am initializing. Now what is the difference between these two? The remaining operation remains as it is. This is still same, okay, this is still same. Run it, the output is still same, okay, output is still same. But the difference is here what we did in the first approach, I'll write here it is, so this is first way, this is the second way, this is second way, right? In the first what we did, variable declaration and initialization we did in the same statement, right? So if you know the loading approach of a class, when JVM will try to load a class, first time it has to search the entire class for static variables and initialize that with the default values. So age will be there, that will be initialized the default value. In the next run, initialize that value variables, static variables, with the hard-coded value if available. So if not available, remains default. Now it is available, and it is initializing with an object. And in the next run, it has to initialize all the static variables with the hard-coded value if available, and it has to execute the static block also in the same order how they appears, right? Static variable and static block both has to be executed in the second run in the same order how they appears in the source file, right? So previously we did this one, now we are doing here. Previously what will happen, hello will be initialized in this point, now it will be initialized in static block. Then what is the difference in this? It is, you can say, almost same, right? Then what is the difference? Difference is output is working exactly fine. This is exactly same, no difference in this case. Here also you will not find any difference, but at the time of execution it has a small difference. If you do the normal execution, say if I just run here test1, if I run here test1, it is execution. Or with this statement, if I run test1 and if I run again test1, no difference, it is exactly same. Then when you will get the difference? Assume the requirement is like this. I just need to load the class. Okay, I just need to load hello class, and I don't want this getInstance. Right, my requirement is like this: just hello class has to be loaded. I don't want the object. It is a singleton. Hello class is a single, it is okay, but my requirement is I don't want this object. I don't want the object. I will not call here getInstance. I just want to load the class. Now if I just want to load the class, and if I follow this pattern, even in this pattern also currently the class will be loaded, static variable memory will be allocated, and object will be created. Now assume inside this class I have so many instance members. Int x is equal to something 99, int one double type array, new double of some size, something like this, right? Then sorry, it is not int double, so double type array it is. Yeah, okay. These members are instance members. When at the time of loading the class, either in this approach or in this approach, when JVM creates an object, inside the object memory for this x and memory for this array, memory for this x and memory for this array also has to be allocated. Right, now you can think how much memory will be allocated when you will create an object of hello. It needs so much memory, right? Because the double size array size is this much size, and each index of this size needs 8 bytes of memory, right? So much memory is required to create this object. But what is my requirement? My requirement is I just need to load the class. I don't want to access the singleton object. Singleton object I don't want to access. I just need to load the class hello. Now if I follow this pattern or if I follow this pattern, any one pattern, in both the cases at the time of loading the class, object will be created. But I don't want this. So if you do like this, if you go with this first approach, you don't have any option to stop this object creation at the time of loading the class. You don't have any option. But if you go with this option, it is inside the static block, but normally whatever we have seen so far, static block has to be executed at the time of loading the class, and inside the static block I am creating the object, and here also it will create the object at the time of loading the class. In both the cases it is going to create the object at the time of loading the class, right? But when you will use reflection, by using reflection, if you want to load class hello, then there is an option that I will just load class hello, but I don't want to execute the static block. Okay, by using reflection, if you load a class, you have an option there that you have to decide. When you are loading the class, you have a choice that if you want to execute the static block, some parameter you have to pass. If you don't want to execute the static block, some parameter you need to pass, right? But for this first approach, you don't have any such option. So if you go with the first approach, and if you load the class by normally how you are loading here, if you load in this way, object will be created. If you load by using reflection, then also object will be created in the approach 1. But in approach 2, if you load the class by using this formal way, normally how we are loading, then object will be created. But if you use reflection to load class hello, then you have a choice that if you want to execute the static block, you can execute, or if you don't want to execute the static block, that also you can extract. So now if my requirement is like this, that I just need to load the class, I don't need any object. Why you don't need any object? Because unnecessarily if you just load the class and if it creates an object, unnecessarily this much memory is wasted in JVM. I don't want like this. I just need to load the class, but object is not required. Then why unnecessarily to waste this much memory? Why unnecessarily to occupy this much memory? So if this is the requirement, what you can do is, don't load the class normally. Load the class by using reflection, and there you say that I don't want to execute the static block. So this is the advantage. And this way you are saving the memory, right? Object will not be just class will be loaded, object will not be created, then this memory is not allocated, right? You are saving the memory. Right. So this is the advantage when you are going with this approach or if you are going with this approach, right? Now depending on your requirement, you have to go either in this way or go in this way, right? Anyone you can follow. Next, this is the second approach. right? In both the cases we are following singleton pattern only. Next is one more approach. Suppose I'll comment again, I'll comment, and now third approach is private static hello, age is null first time. Okay, age is null first time. Now here what I will do is I will not initialize this age even with the static block also. Means why should I go with the reflection loading and all if I don't need the object? What I want is, if anybody is loading the class hello, either it is loading normally in this way, or if you are using reflection, in both the cases object should not be created first time. Okay, in both the cases object should not be created. Then when the object should be created? Object of hello should be created when you say getInstance function. Only when you will tell getInstance function, that time only the object has to be created. Other than this, if you use reflection to load the class, or if you are not using reflection, whatever option you are using to load the class, the object should not be created, right? Then what you have to do, don't initialize in the same statement, or don't initialize in static block, keep it null first time. Then when anybody will tell getInstance, here you create age is equal to new hello and return age. Okay, when anybody will call, anyone needs a object, then you have to call getInstance, and when you will say getInstance, that time only getInstance function has to create an object of hello and it has to return the object. It is not when the loading the class, not when it is loading the class, not in both the type. Now you go to this and check the loading approach. When you will say h1, one reference variable memory will be allocated in the main stack memory, hello class will be loaded. At the time of loading hello class, it will check all the class with the static, for the static variable. Okay, age is there, and age will be initialized with null. No static block, it will not execute. Age remains null. Finish. Done. Class loading is done. When class loading is done, it will go to getInstance. And when we will call getInstance, getInstance has to execute the function call. Then what getInstance will do? Creates an object of new hello, stores into age and returns the age, right? So it has created one object and returned the object, and it is stored into h1. Fine. h1 is ready. Next time again when you will say getInstance, class is already loaded, just call the getInstance, and when you will say getInstance, getInstance has to execute. Again new hello, another object will be created, and again that is going to be returned, right? Again new hello and return. So when you are calling here two times getInstance, it is two different object is creating and two different object address is storing into h1 and h2. Now if I run this, then this should be false. Run it. It is false, and constructor is called two times because two different object is created. Now what problem? It is not following singleton now. Why it is not following singleton? Because we did like this. Every time it has to get an object. And why we did like this? Because so that our class should be loaded in any way. Because of that, first time I have not initialized. Even I have not initialized with static block also, right? So this is approach 3. So this is 3, right? Now in this 3 it is not working. Every time it is creating a new object, so it is not following the singleton design pattern. Now what you have to do is, what I'll do is, here I'll do one validation is, say first time when you will say getInstance, at that time this age was null because this was not executed at that time. So first time when you will say getInstance, age is null, so null should not be returned. It has to create an object, store into age and return age. But second time when you will call, and this age, okay, notice here this age is actually this one. Second time when you will call getInstance, at that time this age is already initialized at first call. Now this second time, it no need to create a new object. Whatever age is already there, just that age object reference has to be returned. It should not create a new one. So in first call only age will be null. Second call onwards, how many times you call? Every time age is already initialized at the first call, and second time onwards it should not create any new object. So here you have to validate, you have to check whether age is null or not, means object is created or not. If object is created, return the created object address. If it is not created yet, then create it, store the address into age and return the age, right? This validation you have to do. Then how will you do? If age is equal to null, if age is equal to null, or for better understanding, actually not required, you can put this in this, okay? If age is equal to null, create an object, return age. If the condition is true, then only if statement is going to execute. If condition is false, then this is not going to execute, right? Now when you will call first time, see, when you will call getInstance first time, at that time class is loaded, age memory is allocated, and it is null. And when you say first time getInstance, age is equal to null, it is true or false? It is true. At that time age is not initialized yet, right? It is true. So if the condition is true, create an object, assign into age and return the age. Done. First call returning is fine. Second time when you will call getInstance, again the control will come into getInstance function, check age is equal to null. Age is not null at that time, object of age is already created in the first run. So this time object age is equal to null will be false. If it is false, it will not create a new object, it just returns age. Whatever previous object is there, that only it returns, and it is. Now if I check here h1 is equal to h2, that gives true, and constructor is also called once. This. Right. So this is the another use of function. Why we are not using directly in this way, why you are using function? If I use a function instead of directly accessing, instead of allowing that to access directly, if I use a function, what I can do, inside the function we can do some validation, we can check some conditions, we can do some authentication, and if all this condition is true, then only return the age. So when you are declaring a function to return any variable like this, main goal is to do some verifications, okay? Do the verification. If condition is true, do something, condition is failed, do some other thing, and finally give the result. So this is the final one, okay? So if you want to design a singleton pattern, what you have to do, declare a class and declare a private static variable which is first time null. Take a function getInstance, in that check the condition and return it, right? And all these approaches also, but these are not going to be used. You have to design it like this. So this is the singleton design pattern done. You can design it like this, okay? Now 100 times you call getInstance, every time it will give the same object reference, and it will not create a new one, right? And for the comparison you can check like this, h3, h4, whatever you want, you take and you can check it, right? So this is singleton pattern. Only one object has to be created and one object has to be loaded. Here one more concept you have to understand. If I go with the first approach, say if it is this one or if it is this one, right? And if it is this one, what is the difference between these two and this one? These two you understand. These two static block, if it is, then you have an option in reflection, I don't want to use a static block, I don't want to execute the static block, right? You can stop it. These two difference you understood, right? Now between these two and this one, what is the difference? These two, if you load a class normally, then at the time of loading the class, object will be created and will be stored into age. But in these, even if you load the class normally, object will not be created first time. When object will be created? Object will be created first time when you will call getInstance function, right? So this type of object creation is called as aggressive, okay? This is aggressive and this is called lazy, okay? This is aggressive and this is lazy, right? Lazy means when you need at that time only it has to create the object and it has to return. And this is aggressive means at the time of loading the class, whether you need that actually or not, at the time of loading the class only the object has to be created and it has to store. So this is called aggressive loading and this is called lazy. Okay, lazy loading, right? So this is very important difference. You need to understand what is actually aggressive and what is lazy means. Aggressive or eager, okay, this is also called as eager loading, or this is called lazy loading, right? Right, so this is singleton design pattern. Now any class you want to create an object and create a singleton pattern, if you want to do, you go in this approach. Okay, this is fine, but the next question is why singleton pattern is required and when you should go for a singleton pattern, right? Why singleton pattern is required? For example, assume I have another class, say class some ABC, okay, ABC class, and in ABC class I have void some add function int x and int y, okay, two you have to pass and it has to add these two and result has to be printed. Say printing result is x plus y, but in this case you have to use the parenthesis, okay, otherwise it will perform concatenation, so it is x plus y. This is one function. Another function is say void show, and show is taking a string type argument that I'll call as message, and it will print here msg is plus msg, right? This is two different functions, but you notice here these functions are instance function, right? In case of, and I'll write it in test2, okay, I'll take another class, so class test2, and in test2 I need to call these ABC functions, okay, ABC functions. And what is a function? You already know. Function is a task, right? Function has to perform some task, okay, and the task here it is assigned. What is the task for the add function? Take two argument, add this two argument and print the result. What is the second function task? Take a message as an argument and print the message, right? This is the task. But these two functions are instance functions, right? Instance functions. Instance function, if you want to call from this location, you have to call an object. You have to create an object, right? So I'm creating ABC A1 is equal to new ABC, right? And I'll call A1 dot add with set 10 and set 20, right? And again A1 dot show function with say hello guys, right? Something like this. Call it done. It is working fine. Result is 30 and message is hello guys. It is working fine. Again, assume I need to call again. Again, what will you do? ABC A2 new ABC and A1 dot add say 90 and 10 A1 dot show function and some message say hi, right? Again I am calling. Now run it again. Again function is called. Sorry, it should not be on A1, it should be on A2, right? We are calling the function, but you have to notice one thing. The ABC class is not having any instance variables. A function is an action which has to perform on some data, right? On some data. Function is an action which is to perform on some data, right? So two actions are defined and it is to perform, but on which data it has to perform? It has to perform on the parameters. When you will call these functions, give some parameter argument value you have to supply, and on that value the function has to perform the operation, right? On this value the function has to perform the operation. But whatever object you are creating for ABC, in that object you don't have any instance variable in class ABC. So if I create the object ABC1 and ABC2, both is two empty object created. And you have to notice here very clearly, the add function which I have called on A1 is not going to perform any operation on the data of ABC because ABC is not having any data. right? A1 function, add function, you have called on A1, which is not going to perform actually any operation on A1 object. Add function is going to perform the operation only on 10 and 20. Same way. On A1 object again you have called show function, and show function is not going to perform any operation on A1 object, and it is performing the operation on the argument hello guys. In this also same. Add function is called on A2, but add is not going to perform any operation on A2 object because A2 is not having any data. The operation